Hello, Math 1050. This is Mrs. Bricky, and this is section 8.5, the binomial formula. There's only one topic here. It does require a little bit of background information, though, so here we go, binomial formula. So the binomial formula helps us handle binomials that are raised to powers. So if it's just a second power, you have strategies to deal with that. You just can multiply that binomial by itself. We get 9x squared minus 3xy minus 3xy, and then a plus y squared. And usually there's some terms that can be combined. And yay, not too bad. If you have a higher power than 2, though, that starts to become very tedious. So if we had this to the 5th power, that means we have 5 of those k minus 7w binomials that we need to multiply together. And you just have to do it bit by bit, distributing as you go, and it would not be easy. So the binomial theorem sort of gives us a tool to expand this binomial to the 5th power without having to, distribute and then keep distributing, just to get your answer straight from the original expression. So here are a few expansions just so you can kind of see. So these ones have already been multiplied together. So starting with a 0 power all the way down to a 5th power. So things that you might observe when you look at this, you might observe that the number of terms is 1 higher than the power. So this has 1 term and it's power 0. This has 2 terms, and that was power 1. For power 2, you have 3 terms. So the number of terms in the expansion is 1 more than the power. So if in a minute we do a 5th power, there's going to be 1, 2, 3, 4, 5, 6 terms. Okay, so that's one thing you might notice when you look at these expansions. The next thing you might notice is that if you focus on x for a minute, the power of x is going down. 3, 2, 1, 0. 4, 3, 2, 1, 0. And again, that's the power. Now we can't see that x to the 0 power on the end because x to the 0 power is 1, but it's there. And you might notice sort of the opposite pattern happening with that term on the other side, the y. It has a 5th power on the far end, and it is sort of decreasing if you move to the left. So as one power is stepping up, the other power is stepping down. So this one would start with like y to the 0, 0 power, 1 power, 2 power, 3 power, 4 power, 5 power on the y. Okay, and then another thing that you might notice, let's see, I'm going to write that one down. Powers step up and down. Okay, and then the other thing you might notice is that if you look at any individual term, if you add the powers together, they are equal to that power that you are expanding. So in other words, every term has the same degree. They're all degree 3 terms. This one's a degree 3 term in x. This one has 2 powers of x, 1 power of y, 1 power of x, 2 powers of y. They always add up to 3 for the expansion of the 3rd power. If you look at the 4th power here, we've got a power of 4. We have a power of 4, power 4, power 4, power 4. So the powers of each term are going to always add up to that overall power. So those are some things to observe that will help us. And then the last thing you might notice is that there are coefficients that are symmetric here. So I have 1, 5, 10, 10, 5, 1. I have 1, 4, 6, 4, 6, 1, 4, 6, 4, 1. They're symmetric. 1, 3, 3, 1, 1, 2, 1. And that would work, if we had a sixth power here, the coefficients would be 1, 6, 15, 26. 15, 6, 1. So always you'll see the symmetry of those coefficients. Okay, so here is the binomial formula. The binomial formula tells us if we want to expand a plus b to the nth power, we can get our coefficient right here, and we'll talk more about this, but this is the coefficient. Then you'll have the first term, which is called a on this, with an n power, and the power is going to decrease. So n minus 1, n minus 2, all the way until you get to the a to the power 1 and a to the power 0. And then that second term, which is called b on this formula sheet, it starts with a 0 power and increases b0, b power 1, b power 2, all the way until it's b to the power n minus 1, and then finally b to the power n. So we can go straight from this into our expansion. And remember, you'll have n plus 1 terms. So if this is power 5, you'll have 6 terms. Okay, so let's talk a little bit about that NC0, NC2, NCN. That is a factorial number. If you have NCR, it's equal to n factorial divided by r factorial times n minus r factorial. And that's, we could calculate that. We've practiced with factorials, but there is a calculator button for NCR. In the little calculator, it's in the probability button, the same place that the factorial is, but you should see it. If you hit that PRB button, you should see that NCR choice. So each term, when we expand, is going to have this form of NCR times a to the n minus r power times b to the r power. Okay, so let's do that expansion. Now, I'm doing the second power expansion. Even though we could easily multiply it out, I think it's nice to see how this binomial theorem is working. The way that it's written on your Dixie State sheet, reference sheet, is like this. The binomial theorem is a plus b to the n power equals the sum. So they're writing it as a summation. It's the sum of, and this is another symbol for NCR or NCK. So that's just your little combination right there, your little C button on your calculator. And then this is showing you A is going to start with power n because it's going to start with K0. B is going to start with that power 0. And we're just going to add those terms up to get the expansion. So it's written in summation notation. It means just as what I showed you earlier. So in this example, our A is going to be a 3x. And for our B, we're going to take that to be a negative y. So A is 3x, B is negative y. And you do want to kind of take that negative sign with the y there. So our terms are going to start with, our power here is 2. So our first term has a coefficient of 2c0. Start with 0 there. And then the first term, 3x, has that power of 2. So we're going to start with that power 2. And the negative y is going to have a power of 0. The next term will have a coefficient of 2c1. So starting with 0, 1 is next. And now this power is going to step down. So it's going to be a 3x to the power 1. And our negative y's power is going to be stepping up to 1. But you can see in both cases that powers add up to 2 for right now. All right, and then our third term, this is power 2, so we're going to have 3 terms. So this is our last term. That's going to be 2c2. So I started with 2c0, I had 2c1, now I have 2c2. The 3x power is stepping down, so this is going to be a 0 power, and the negative y power is the one stepping up, so that's going to be 2. And again, those 2 powers, when you're writing this sort of raw form, they should add up to 2. Okay, so if we simplify this in your calculator, you can type in that 2c0, and I'll show you more about that calculator button on my next screen. But if you type this in, this is a 1. The 3x is being squared. So that squaring power applies to the 3 and the x. You know, it's the same as having a 3x multiplied by a 3x. So that's a 9x squared. And then anything to the 0 power is just a 1. So that term simplifies to 9x squared. Our next term starts with 2c2. If you typed that into your calculator, you would get a 2. 3x is the power 1, so that's the same as 3x, and negative y to the power 1 is the same as negative y. So this ends up being negative 6xy. And now we're ready for our last term. If we type 2c2 into our calculator, that's 1. 3x raised to the 0 power is 1. And then negative y squared is the same as y squared. So our last term is y squared. So that would be our solution. And that is the same answer as I got when I multiplied it out by hand distributing earlier. So, you know, it's probably easier on something like this to just distribute, but we're going to do our 5th power one next. So if you aren't sure where to find that NCR button in your calculator, if you need to calculate 4C2, if you hit that probability button in the TI-30, NCR is that second choice down right above the factorial button. So you might probably enter that 4 first, then get that NCR notation on your screen, and then you can enter the 2 and hit enter. If you hit NCR first, you'll have to just like arrow over so that you can put in that first number. So it's a good idea to try to remember to type that leading number first. Okay, so let's expand this 5th power. We have x minus 7w, and it's raised to the 5th power. So our coefficients are going to be these little combinations. So using that little C button in your calculator, our power is 5, so we're going to have 6 terms. So starting with 5C0, the next, and sometimes a good way to, well, that's fine, 5C0, starting with 5C0, the leading term is an x, and then our second term is going to be negative 7w. Make sure if it's negative that you use that sign as well. So our first term is going to have a power of 5. Our second term is going to have a power of 0. Second term in the binomial. Okay, so that's the first term of our expansion. Now we have 5c1 as our coefficient. The x's power is going to decrease, while the negative 7w's power is going to increase. And then we're ready for our next term, 5c2. The x's power is decreasing. The negative 7w's power is increasing. Now we're ready for our next term, 5c3 is the coefficient. The x's power is decreasing, so it's at power 2 now. The negative 7w's power is increasing, so it's at a power of 3 now. And remember, you can always check and make sure that you get that sum of 5 on the powers. Ready for the next term, it's going to have a 5c4 combination. The x's power is now down to 1, while the negative 7w's power is at 4 now. And we are on our last term, 5c5. the x's power has gotten down to 0, and the negative 7w is at a power of 5 now. Okay, so if we clean up and simplify these terms, 5c0 is 1, 5c1 is 5, 5c2, and you would type these in your calculator to get them, but I'm just going to write them out. It is symmetric, remember, so if you've calculated half of them, if you've calculated the 1, 5, and 10, it's going to go back down 10, 5, and 1. Okay, so those are our coefficients. If I simplify this variable part of it, the x is a power 5 and the negative 7w is the same as 1. Oh, sorry, my computer's being weird. Okay, times 1. So that's our first term. The second term has that coefficient 5. The x has a power of 4. A negative 7w to the 1 power is a negative 7w. I'm going to kind of simplify these terms in 2 steps. You may do more, simplify more in 1 step on your own. X to the third. That negative 7w being squared gives me a 49w squared. The x squared stays the same. Negative 7w raised to the third power is negative 343w to the third power. And negative 7w to the fourth power is 2,401w to the fourth. X to the 0 is just 1, and that negative 7w to the fifth is negative 16,807w to the fifth. Okay, so one last little simplifying step. That first term is just x to the fifth. That next term is going to actually be a minus 35x to the fourth w. Next term is going to be 10 times 49, 490, x to the third w squared. Then we have a minus 3,430, so just timesing the coefficient here by 10. The x is squared and the w is to the third power. The next term, if I multiply and simplify that out, it's 12,005x w to the fourth. And then that last term is minus 16,807 w to the fifth. Okay, so that's a lot, right? Well, luckily, your topic doesn't actually make you expand out an entire binomial. What your topic is going to do is going to have you focus on one particular term and finding the coefficient of that term. So maybe it asks you to find the xw to the fourth coefficient. Your job is to calculate this number. So in some ways that's easier because you don't have to do quite as much work, but in some ways it's more difficult because you have to know how to find a particular term. So notice that our little combination at the front, 5c4, that power of the second part of your binomial is matching here. So whatever power I see here, it matches that. And so we're going to use that idea. So on your formula sheet, it looks kind of awful. It says to find the kth term, you use this little expression right here. And that is, you'll see this is a 4 and a 4. On my formula sheet, that lists it as a k minus 1 and a k minus 1. And the reason is because this is not the fourth term in the expansion. This is the first term, second term, third term, fourth term. It's actually the fifth term. So when we are getting the fifth term, we use a fourth power and the fourth combination. So I think the notation here is kind of difficult to interpret, but the important thing is to realize that whatever power you use here, that's the combination, the second number in the combination. So we want to use the binomial formula to find the coefficient of the y to the third x to the seventh term of this expansion. So our a is 3y and our b is x. Our overall power is 10. So our coefficient or our term is going to be 10c, and you're going to use the 7 there. 10c7. You want to look at the second part of the term. You don't want to look at the y to the third power. You want to look at the power on the b. So that's going to be a 10c7. Whatever a is going to be raised to the third power, and whatever b is going to be raised to the seventh power. So you do need the 10c7 for sure, but especially if there's a coefficient as part of one of your terms in your binomial, you want to make sure that that gets the power 3 or whatever the power is as well. So 10c7 is 120. This is a 27y to the third and an x to the seventh. And again, you want to watch that the power you use here is the same as the number here. And on the formula sheet, that's listed as a k minus 1. And so then if we simplify this a little bit, the 120 and the 27 can be multiplied together. That gives us 3,240 y to the third x to the seventh. So Alex just wants the coefficient, so you would just type in 3,240. If that coefficient is negative, Alex doesn't want you to put that negative in. So let's do one more example of this. So we're trying to find the coefficient of the t to the ninth p term. So that power on p is 1. Okay, so our a is t and our b is negative 2p. Don't forget to have the negative with that 2p. So our coefficient is going to start with 10c, and we want to use that power on that second part of our binomial. So this is going to be 10c1. That's multiplied by a to the power 9 and b to the power 1. So cleaning it up a little, 10c1 is 10. The t has a ninth power, and we're multiplying by negative 2p because negative 2p to the power 1 is just negative 2p. So this is negative 20 t to the ninth p. So in Alex, we would answer that our coefficient is negative 20. All right, so that's the topic. It's just finding the coefficients. So let me know if you're having any problems with that. Thank you.